review of what we talked about last time, midpoint and distance. So let's say that I have 2 points A and B here and these coordinates, and I wanted to find first the midpoint, so I'm looking for a coordinate between the two. What I'm going to do is, of course, this M is the average of those 2 points. So I might say xm, ym is equal to the average of the x's, so negative 3 plus 5 divided by 2, and average of the y is 2 plus 4 divided by 2. So then here I have 2 divided by 2 is 1, 6 divided by 2 is 3. So this point 1 comma 3. And then if I wanted to find that distance, remember that this is the hypotenuse of a right triangle. So then here I can say, well, I went from negative 3 to 5, or 5 minus a negative 3 is equal to 8. And then here I went from 2 to 4, so 4 minus 2 is equal to 2. So distance is equal to 5 minus a negative 3 squared plus 4 minus 2 squared is equal to, this is 8 squared or 64, plus 2 squared, which is 4, the square root of 68, and I could approximate that or in a calculator to get a decimal, or I can just say that is my distance, this many units. Another example that we looked at, another example here is when we have a midpoint and an endpoint and we need to find the coordinates of the other endpoint. So I have a point here, and let's just draw it extending up like this. Maybe this is Q, M, and this is, say, P. My midpoint is negative 8, 12. Q is negative 3, 4, and I need to find the coordinates of P. So remember that the coordinates of P and Q, the average of those will give me M. So this is x comma y. So the way I can solve this problem is I can say negative 3 plus x divided by 2, that should give me negative 8. And 4 plus y divided by 2 should give me 12. So if I solve this, negative 3 plus x is equal to negative 16, where x is equal to negative 13. This 4 plus y is equal to 24, or y is equal to 20. So the coordinates are negative 13, 20. Okay, I have this guy right here. Okay, so let's start with our topic for today, measuring angle pair relationships on 4015. And so I just wanted to start by taking a look at an example like this. We have a lot of different things going on there, and we want to look at how I might first find some of these unknown values. Well, you may remember from previous study that, for instance, this angle and this angle are going to be congruent, and that's known as vertical angles. When I have two intersecting lines, these guys are opposite, so this would also be 127 degrees. When I have a straight line like this, these two are called a linear pair, or they're supplementary, so this should equal to 180 degrees. So I have 53 degrees is going to be that angle there, and then these are vertical, so also 53 degrees. So here, because this is a right angle, I know that the relationship between these two angles here and here are called complementary, because they both add to 90 degrees. Sometimes I say they're a couple, they're right for one another, because complementary couple, anyway, so you can remember that. If this is 54, then if this creates a complement, this must be 36 degrees to equal to 90. Vertical angles makes this 36, etc. The way I'm going to name these angles is, for instance, if I say something like angle Q, or sorry, angle C, that makes absolutely no sense at all, because I don't know, it's angle C here, 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 or here. But if I want to name this angle 127, I'm going to say angle BCD. And if I want to refer to the measure of this, I'm literally going to put M for measure is equal to 127 degrees. If I just say angle BCD, so for instance I might say angle BCD is congruent to angle ACE because they are vertical angles, I can make this statement, but if I'm talking about their measurement, I need to use this M here. Okay? Okay, so here these are the sides of the angle, and then this is known as the vertex. So this angle I could name either as angle A, which would be the same as saying angle CAB, where this is the vertex angle. I can only say this if it's very obvious that I'm talking about this angle. Remember in our previous example, here I couldn't say angle C. In fact, I couldn't use that for any of these. I would need to name them by 3 different angles, or I could put in number 1 or something like that. So to make it easier, I could just say angle 1, okay, to make that clarification much easier. So we talked about this idea of definition of congruence before with segments, but if I'm referring to the angle measure, I'm going to say the measure of angle A is equal to the measure of angle E. But if I'm referring to the angles themselves, I'm just going to say angle A is congruent to angle E. Okay, and I want to be really clear with that notation. Also, if I was to draw another angle in here, let's say this is G, I would know that the measure of angle DEG plus the measure of angle GEF is equal to the bigger angle. I'm going to say measure of angle 1 because I named it like that. So just like we had before, I have this angle addition. This plus this equals the full angle, and we'll be using that later on. Okay. Quick review from middle school. Acute angle. Oh, he's so cute. He's less than 90 degrees. So he's 0 degrees less than the measure of angle B, less than 90 degrees. Right angle here equal to 90 degrees. Obtuse is between 0 and 180. And then a straight angle, this one doesn't really look like an angle, but it forms like a line. I can say is measure of angle U is equal to 180 degrees. It's called a straight angle. The difference here, I think you're familiar with these two definitions, complementary, supplementary, right? This is 90 degrees, this is 180 degrees. What you may not be aware of is this idea that complementary and supplementary, they can either be adjacent or touching or non-adjacent. So one key definition that we have is so adjacent, non-adjacent, adjacent, non-adjacent. Supplementary angles could be adjacent or non-adjacent. When they are adjacent and supplementary, we call this a linear pair. They form a line together and they are touching. So notice that a linear pair is not always, so this is always supplementary, but supplementary angles do not always form a linear pair. And we're going to use this definition a lot, linear pair, and we can prove relationships using this relationship here. Vertical angles we talked about, so 4 and 6 are vertical angles, 3 and 5 are vertical angles here, and we'll learn that their measures are equal. Okay, so I want to go through a couple of quick examples with you. Here it just says tell whether the angles are vertical angles, linear pair, or neither. So we see 1 and 4. Yep, those are vertical angles. 3 and 5 here. Those are nothing. There's no relationship between those two. Nothing. 7, 8, and 9. Those. Now, when I say a linear pair, even though this equals 180 degrees, it is not a pair. So I'm going to say nothing. Okay? 1 and 2, linear pair. 2 and 3, vertical. 5 and 6, linear pair. 6 and 7, nothing. And 5 and 9. 5 and 9, no relationship. Okay? Alright. So I'm going to give you some questions to take a look at here. Go ahead and see if you can answer these. You can pause the video and then I'll work through them in just a minute. Okay, so is this a right angle? What can we name the right angle that's here? So again, I want to name it PQR. So I can say either the measure of angle PQ, no, not RS, is equal to 90 degrees. Okay. I don't want to say angle Q because it's unclear which angle I'm referring to. This one says, given that the measure of angle LKN is equal to 145 degrees, find this angle, LKM, and find this angle here. So summing together, 2x plus 10 plus 4x minus 3 is equal to 145 degrees. 6x plus 7 is equal to 145 degrees. So 6x is equal to 138 divided by 6 divided by 6. So x is equal to 23. So then I want to go back, find the measure. So I'm going to plug that in. 2 times 23 plus 10, 46, 56 degrees. Okay, and then MKN should be 145 minus 56. I'll just give you a few other questions to try on your own, and then we can talk about them next class. So I'll just put it here, you can pause. Okay, so for after you're done completing these, tonight's homework is 1.4, 1.5 from the textbook, and that's listed on Moodle and on the iCal site. Okay, enjoy your Typhoon Day.